That contains a polyatomic ion. How do we name the ionic compound that contains a polyatomic ion? Okay, let's go over the key concept from chapter 9.2. To name a compound containing a polyatomic ion, state the cation name first and then the anion name. If a cation is a metallic element that has more than one common ionic charge, include a Roman numeral in the cation's name. Okay, so let's do the first one, NaClO3. Okay, keep in mind that sodium is going to be monoatomic, ClO is going to be polyatomic. So let's find the name for Na. Na is sodium, and ClO, which I messed up last time I'm recording this video over again. ClO is right here, hypochlorite. So we have we have sodium and we have hypochlorite, ClO. So the name of this compound will be sodium hypochlorite. Okay, notice that I did not write a Roman numeral here because sodium has always 1+ charge. There's only one for alkali metals and alkali earth metals. There's only one specific type of charge. For group 1 elements it's +1, and for group 2 elements it's +2. Okay, let's look at the next problem. Notice that here we have two polyatomic ions, NH4 and C2O4. So we gotta use the chart over here, which the polyatomic ions are found right here in this periodic table of ions above the monatomic ions. So here's the polyatomic ions. NH4, the positive ions are at the bottom right of the polyatomic chart. All the rest of these are polyatomic anions, and negative charge poly ions. So let's find NH4 and C2O4. So NH4 is ammonium, and let's find C2O4. C2O4 is oxalate. So the name of this will be ammonium oxalate. All right, let's do the next one. Fe, okay, ClO3, okay. Iron is going to be monatomic. ClO3 will be polyatomic. So let's find the name for Fe and ClO3. And here's a problem because we got to determine the charge of this iron. I'm going to erase this because I did this previously. What is the charge of this iron? Well, in order to do that, we need to find what ClO3 charge is. If we find ClO3 is right here. The name of it is chlorate, and it has 1- charge. So I'm going to write 1- or just a negative sign. But notice that we have 3 of them. So 3 times -1 is -3 overall. So what's going to be the charge of this iron if it has to be neutral? If this polyatomic anion is 3 negative overall. So this has to be 3 positive. Okay, so which iron are we going to use? Iron 3+, which is iron Roman numeral 3. So iron Roman numeral 3, and ClO3 is chlorate. So it's iron 3 chlorate. Okay, let's look at the next problem. KClO. Okay, K is monatomic, ClO3 more than 1 is polyatomic. So K is going to be a monatomic, group 1, which is potassium. Notice that we only have 1 charge for potassium, so we don't need to write a Roman numeral, so it's just potassium. And let's find ClO. ClO is hypochlorite. So it's sodium hypochlorite. Okay, let's do the next one. Li2SO3. Li is monatomic, SO3 is more than 1, polyatomic. So let's find the name for Li. Li is lithium. It only has 1 charge, so we don't need Roman numeral. So it's lithium. And SO3, let's find SO3. SO3 is here, sulfite. So lithium sulfide. And that's it. All right, the next one. Okay, this is probably the hardest one. Let me erase this. All right, so SN is one element, so it's monoatomic. PO4 is two elements, so it's polyatomic. So let's find the name. Let's look up SN. SN is 10, but there's a problem because we got to figure out if it's 10-2 or 10-4, if it's a 4+ charge or 2+ charge. Okay, how are we going to do that? Well, let's look at the charge of polyatomic anion. PO4 is right here. PO4 is phosphate, and phosphate has a 3- charge. So this is 3- charge, and we have 2 phosphates. So 2 times -3 is -6. And notice that we have 3 10s. So 3 times what will give us, if this is 6 negative, we know the cation overall charge has to be 6 positive. So 3 times what will give us 6 positive? The answer is 2 positive. So this 10 has to be 10 Roman numeral 2 because it's 2 positive charge. 3 times +2 is 6 positive. 2 times 3 negative is 6 negative. So that's going to be neutralized right here. So it's going to be a neutral ionic compound. So let's write the name for this. SN2+ is 10-2. 10 Roman numeral 2. And then PO4 is phosphate. So it's 10-2 phosphate.